All right, everyone. I am ready with my Google Colab. So first thing first, what we are going to do, we are going to connect our data with it. So for that, what you are going to do, you are going to click on this folder, which is at the extreme left hand side of yours. When you are going to click on it, sometimes it is going to show you that you are going to connect to a runtime, and then it is going to show the folder in front of you. So what you are going to do, you are going to click onto this option which says upload. When you will be clicking on this upload, you can actually take the data and you can click open. Sometimes it shows this error and you can avoid this errors. That's completely all right. All right. Now let's quickly take the libraries which are needed for this particular session. So we are going to upload all these libraries. The first one, the first library which you are going to take, I'm not going to generate. You can get started by generating also. So step number one, and step number one is import libraries. First is import pt. Once you are done, import numpy as np, import or from sklearn dot model selection, import train test split from sklearn. This is in the next line. sklearn dot pre-processing board standard scalar pre-processing. Yeah, see. Okay. Make sure that standard scalar when you are writing S are capital input. Now the next one, from dot import classification report, that is going to be confusion matrix, which we have discussed already. And I want ROC AUC score. So basically with that, what we are going to do, with that, we will be considering the score. And the last one which we have taken, that is from sklearn linear model import linear regression. So here we are not using this segment. Here we are going to import TensorFlow flow as TF. Import matplot lib dot py plot as PLC. Yeah, and I am going to import eborn as essence. So these are all libraries which you are going to put. Like before we get started with our machine learning part, because all these libraries, now let me quickly make you understand. So pandas is basically to read the data set which you are going to upload. NumPy is to run all the mathematical formulas to simplify the complexity. So that is what you will be, that is why you will be using NumPy. Scikit-learn machine learning model, this is for splitting the data into test and train. This is for pre-processing, how you are going to segregate and compilation is going to work. Now, this matrices is basically the confusion matrix which you are going to take, as well as it is going to show you the accuracy. It is not this is accuracy score. All right. Yeah, I'm going to just take this. Otherwise, it is going to show an error. The next is import TensorFlow. TensorFlow, I have already shared what is going to be the role. So this is one new thing which we are introducing in this particular module, as well as Matplotlib PyPlot, which we have been doing in the previous session. So now step number 2, this is step 2, and step 2 is going to be load data set. Now, how we are going to do? We are going to create a data frame. df is equals to pd dot read CSV, and our CSV is going to be R. Now we are going to go over here, which we have already uploaded, and we are going to copy the path. So we are going to paste the copied path over here. If you want, you can visualize also, or you can move to the next step. So I'm going to move to the next step because we have already visualized the data set beforehand, right? We have seen how the data matrices are going to be there. We have analyzed it. Now this is step number 3. And step number 3 is going to be features and targets. So features are going to be X, which you are going to do. I'm going to take capital X is equals to df dot drop. What we are going to drop over here. All right, I'm so sorry. df dot drop, and I'm going to drop what? I'm going to drop diabetes, diabetes, and that is from axis 1 is equals to 1. I hope you all remember why we are doing this. Otherwise, it is going to show an error of two-dimensional. And now we are going to introduce y is equals to df diabetes. So this is how you are going to create. You are going to define what is going to be your input and what is going to be your output. So x is going to be our input and y is going to be the output. Now what we are going to do, step four, that is train and test. All right. So that is what we will be doing. For that, what you are going to do. So you will be putting X train, the same thing, the way you have done previously. X test, Y train, Y test is equals to test is equals to train test split X Y test size you will be giving, which is going to be test size is equals to 0.2. If you want, you can increase or decrease also. We are going to give random state. I hope you remember why we are taking random state. You can take 32. It's completely up to you which one you would like to take. You can take 32, you can take 42, completely your choice. Once you are done with that, now you are going to call upon the next step. So I'm going to put step 5, and that is going to be feature scaling. So remember, I have called upon the scalar, standard scalar. So that is what we will be doing. scalar is equals to this is the method which we have called upon. And I'm going to put X train scaled. That is going to be scaled is equals to, now we are going to fit it, right? Scalar dot fit. Previously, what we used to do, model dot fit. Now here we are doing scalar dot fit. Now it is going to transform X train. So this is what you will be doing. Now, similar thing you are going to do for X test. Scaled is equals to scalar dot transform, and then you are going to put X test. Once you are done with that, you will be now building the enhancement of your model. So let's quickly do that. Step 4, 5. This is going to be 6. That is your build enhanced model. And this enhanced model is going to be, first of all, you are going to put model is equals to, now here we are introducing TensorFlow from Keras dot sequential tab. Now you are going to put, wait, delete that, because over here what I want, I needed to start sequential, and now here you will be starting. All right, so I'm going to get started with this, and I'm going to put, now over here tf dot keras dot layer dot dense. Now remember, I have already explained in front of you that we will be using dense layer, right? So 32. Now we will be calling upon activation function. Activation we are going to take from ReLU. Yeah. Here we are going to take input, that is going to shape is equals to, that will be X train dot shape, and shape is going to be 1. All right. Now, once you are there, you are going to put this, and you are going to take off this. This is the one which you will be doing. After ReLU, you are going to, now this is done. Now, what you are going to do, you will be moving over here TF. I guess, yeah, this is good. TF dot Keras. Now you are going to take the second layer of that. Okay. So TF dot Keras dot layer. Again, you are going to call upon the dropout layer. Okay. Layers. And here also, it's like, it's not layer, it's layers. Here also put layers, and in the layers now you are going to call upon dropout. Dropout layer we are going to take, that is going to be 0.2. It means 2% you will be taking. Now you are going to put tf dot keras dot layers dot dense. It is going to be dense, and then you are going to put 64 exactly, not 64, 16. 16 and activation is equals to, again, same. Relu will do the activation here also. And I'm going to put this now tf dot keras dot layers dot dense. And in dense, now we will be taking mm, 1 and activation. Again, we are going to take activation now sigmoid, because what we want one result out of all, and the activation is going to be by sigmoid, as I have already explained in front of you why we are using sigmoid. Sigmoid is going to help you to give answer only in 0 and 1, whether the person is diabetic or not. So that's why we are using sigmoid. So I'm going to use small SIG and sigmoid. ACTIVATIO activation. Right. Done. Now you have to understand this last layer, which is of dense. This is basically your output. This is going to tell you whether it is the person is diabetic or not. This is with Relu, it is going to create epochs and batches, which is going to balance, you can say, weights as well as biases. It is going to handle to provide you a better accuracy. All right. And then the next step, which we are going to do, that is going to be your compilation. You will be compiling the model. So these are all things which you will be doing. So today we are going to do till here. In the next session, we are going to do the rest of the part. Now, let me quickly explain all these steps in front of you. Step number one, what we have done, we have we have imported all the libraries. We have imported pandas as PD. We have imported numpys as NP. We have taken, and if you are going to click onto this, like if you are going to just hover, you will see that what numpy does. Numpy provides an array object. It converts linear algebra, forward transformation, random number generation, fast mathematical operations over arrays. So all these things you can do by using this module. Then we have scikit-learn, which is also a module. And now what this module does, this module is going to train and test and split. So this is one of the, you can say, module which is behind your machine learning. And that's why we are learning it. TensorFlow is basically used to provide a deep sense, basically using deep learning from Keras. It provides you the analogies using exactly or mimic like human brain, right? First of all, what we have done, we have load the data set. We have read the data by putting it into data frame. We have uploaded the data, which is diabetes data 300.csv. Step number three was we have created our input and output, which we have converted into X and Y. By dropping diabetes, which was our output, we have created our input. And I had already explained why you have done this. It is basically rather write the entire code and then convert that into two-dimensional, because machine learning models doesn't run, or test and train cannot happen on one dimensional. So therefore it requires multi-dimensional. And X is only a single dimension. That's why what we are doing, we are just dropping the diabetes, which was output from the entire data, so that we can get the input in it. Therefore, step number four, which we have done, that was about X train and test split, which we have done by using train test split module, by which we have called upon using scikit-learn model library. We have used by taking X-train as text, that we have been doing from the previous classes. All the steps are same, as I promised you that if you are going to learn all four steps, in which load the data, check the patterns, Thereafter, you are going to split the data into test and train. Once you have split the data into test and train, then you are going to evaluate the model. This is what we are doing. Only the mathematication part, the classification, these are the things which are different. Rest, the structure of all machine learning models are same. This is what you are doing. Therefore, we are doing featuring by using scaling module. So previously we used to create model by using model.fit. Over here, we are doing scaling so that there is no, you can say, overfitting in the model. So first of all, we have done test X train, then we have done X test. The same thing, we have transformed the model for X train and X test. So these are all the steps which you have done, and we have been doing all of it, right? Previously also. So I hope now you get clarity about it, that how you will be doing, what exactly is happening in all these models. Now there is one thing which you must have thought upon, that why it has not. So over here, this is scalar dot fit, but it's not there in the test, right? So it's basically why, because when we are training, we require more, more sort of data, and it performs standardization by centering and scaling it. And that's why this part we have taken in the train, not in the test, as you can see over here, because testing data is very small, which is just, you can say, 20% of it. Thereafter, what we are doing, we are going to build and enhance the model by calling upon Keras from the TensorFlow. So here, basically, we are using TensorFlow by calling, and these differently. The first one is basically your input. Then thereafter, we are doing dropout. Dropout, I hope you all are aware of that to avoid overfitting, we are using dropout layer. Okay, which we are taking only 20% of it. Thereafter, by using the activation function ReLU, we are getting the last one. This is basically the output using sigmoid, which is going to give you the output only in binary, whether the person has diabetes or not. So this is the result which you will be getting. This is the entire model. Now I'm going to take you quickly to the data set which we are working with. So we are using this data set basically. It has all these value. So if you talk, so these four are going to be your input, and this diabetes, which is the last one, which has only 0 and 1, this is your output. So that's why अगर मैं पहली चार को ड्रॉप कर दूं तो मेरे पास आउटपुट आ जाएगा, लेकिन अगर मुझे इनपुट चाहिए तो वो बहुत ज्यादा इजी है। अगर मैं पूरे डेटा के अंदर से अपने आउटपुट को डिलीट कर दूं तो मेरे पास सिर्फ इनपुट्स बचेंगे, राइट? सो दिस इज व्हाट वी हैव डन इन दिस पर्टिकुलर स्टेप, right? As you can see over here, where I have put this drop dot diabetes. So this I have done by using the same methodology. Now I'm going to take you to the data sets once again, and I'm going to show you some more thing. Now यहाँ पे कोई पैटर्न नहीं है, डायबिटीज किसी को भी हो सकती है, बट यहाँ पे एक कोरिलेशन है, डिपेंडेंसी है। जिस डिपेंडेंसी को आप यहाँ से देख सकते हो कि कुछ ना कुछ पैटर्न बन रहा है। अगर बीएमआई बढ़ रहा है तो डायबिटीज के चांसेस भी बढ़ रहे हैं, फ्रीक्वेंसी बढ़ रही है, राइट? आप यहाँ पे क्लियरली देख सकते हो। अगर बीएमआई 20 से ऊपर जा रहा है और ऊपर जाते जाते आप देख पा रहे हो कि ग्लूकोज लेवल भी अगर ऊपर जा रहा है तो यहाँ पे डायबिटीज के चांसेस ज्यादा है। कुछ केसेस में ऐसा भी है कि ग्लूकोज भी ऊपर जा रहा है और बीएमआई भी ज्यादा है, राइट? बट यहाँ पे 40 वाले को डायबिटीज नहीं है। सो कुछ केसेस में ही ये डिपेंडेंसी है, जरूरी नहीं है कि 100%। तो यहाँ पे जो आपकी एक्यूरेसी आएगी वो जरूरी नहीं कि आपकी एक्यूरेसी 100% आएगी। आपकी एक्यूरेसी इन बिटवीन 50 to 60 के बीच में आएगी, राइट? क्योंकि सारे केसेस जरूरी नहीं है, किसी की फिटनेस पे डिपेंड करता है कि जीन्स आपके हैं या नहीं है। जहां तक डायबिटीज का सवाल होता है, डायबिटीज में हम ये देखते हैं ना कि हमारे किसी को घर में डायबिटीज है या नहीं है। ज्यादातर केसेस में क्या होता है कि जिसके घर में मम्मी पापा को डायबिटीज है, तो बेसिकली वो पेरेंट्स के थ्रू बच्चों में भी आ जाती है। सो देयर आर एक्सटर्नल फैक्टर्स ऑल्सो। सो हम यहाँ पे एक्यूरेसी जो मेजर करेंगे दैट इज गोइंग टू बी इन बिटवीन 50 to 60। केटरिंग की 50 से ज्यादा जो भी एक्यूरेसी आपके पास आएगी, अगर आपकी एक्यूरेसी 50 से ज्यादा है, दैट इज कंसिडर्ड एज अ गुड मॉडल। और उसी मॉड्यूल को हम एक अच्छा मॉड्यूल और एक अच्छा मॉडल कंसिडर करते हैं। और यही आज हम फाइंड आउट करेंगे, और इसी मॉडल के साथ आज हम इस मॉडल को क्रिएट करेंगे। सो ये सेशन यहीं तक था। दिस सेशन वाज स्टिल हियर। कीप प्रैक्टिसिंग। इन द नेक्स्ट क्लास वी आर गोइंग टू कंपाइल द मॉडल. We are going to check upon the accuracy, and by using PyPlot, you can say Matplotlib, we are going to see the correlation also. So stay tuned and keep learning. Let's see how this model is going to bring in efficacy in your work, and keep trying different data sets also. Just don't rely on the data which I am providing to you. These are all learning sessions. If you are going to apply this learning in your own data set, I think you are going to learn a little bit more. So thank you everyone. Stay tuned.